Hello friends, I am Dr. Rajesh and I am back with my new video. So in this video we will discussing some problems. First problem is, if every element of a group is its own inverse, then show that group is abelian. Let G be a group such that every element of a group is its own inverse. Means every element is inverse of its own. For an example, we have two elements be any two elements. Then by the given condition, inverse of x is equal to x itself, inverse of y is y by given condition. And required to prove G is abelian group, that is xy is equal to yx for all xy belonging to G, means its element commute with each other. Since xy belongs to G, therefore their product will also belongs to G, because G is a group. G is a group implies closure property is satisfied. Closure property is satisfied means the product of two elements is again in the G. This, and also using the given condition. The given condition is that for every element of G, since xy belonging to G, so this inverse is equal to this much. This further implies that, and we know that how to open the inverse. This y will come first, then will x. So the inverse opens in the reverse order. So this will be y inverse x inverse is equal to xy. By using 1, y inverse is y, x inverse is x, xy. This implies that xy is equal to yx. So we have proved that, and this is holding for all xy belonging to G. This implies that G is abelian. So that was required to prove. Next we will prove the next theorem, and this is also very important theorem, and the next statement is given by, if a square is equal to identity, and this is holding for every element of G where G is a group, then prove that G is abelian. Now let G be a group. This dot is a binary composition with respect to which it forms a group, and we have already studied the group. So this is a group such that a square is equal to E, and this is holding for all A belonging to G. This is a symbol for symbolic notation for all. So this G is a group such that A square is equal to identity for all A belonging to G. A square is equal to identity implies A square can be written as A dot A is identity. So pre-multiplying both sides by A inverse, and we know that A inverse E is equal to A inverse because we this is the property when x multiplied by e multiplied by x gives the same element, and this is holding for all x belonging to G. Also, now using the associativity, so we can write it something like this one, and this is equal to A inverse, and we know that A inverse multiplied by A gives the identity A is equal to A inverse, and right here because A inverse A is equal to identity, and when identity is multiplied by any element gives the same element A inverse, again you can write xe is equal to ex is equal to x, and for all x belonging to G. Therefore G is a group such that every element of group G has its own inverse. That we just proved, because this condition is also holding for all A belonging to G, since A was any element, and so this condition is holding for all A belonging to G has its own inverse. Okay. Next, we see that every element of group G has its own inverse, that we have proved. Let A, B are two elements, then by condition A, where we are saying that every element has its own inverse, then A inverse will be A, like the last theorem. B inverse will be B. Since AB belonging to G, this implies that their product will also belong to G, closure property. G is group, hence closure property satisfied. Okay. Now AB belongs to G. This implies that AB inverse is AB as such. Now opening the inverse, and we know inverse opens in the reverse order. If we have B at the second place, then B inverse will come first, and A at first place, A inverse will come at the second place. So this will be AB. By condition A, we know that B inverse is this, B inverse is B, A inverse will be A, and AB is equal to A by A. Therefore AB is equal to BA, and this is holding for all AB belonging to G. This implies that G is a abelian group. So we have proved this theorem, and these both are very important theorem from the examination point of view. So I would recommend all the students to go through these problems very carefully, and if they have any problems they can ask me but in the comment section by raising your query. I will definitely reply you, and I will be with you very soon with my next video lecture. Till then, keep studying, stay at home, stay safe, and if you have liked the video, please like, subscribe, share and comment. This is Dr. Rajesh saying a goodbye. Thank you very much. Thanks for watching.